So again, section 3.1, exercise 34. And here in 34, we're given the function g of theta is equal to secant theta. And we are asked to find the absolute max and min on the interval minus pi over 6 to pi over 3. Okay, so that is on the unit circle idea. We have a minus pi over 6, which is about 30 degrees there. Minus pi over 6 up to pi over 3. Pi over 3, which is about 60 degrees. About. It really is 60 degrees. Don't know why I said about. But so we're looking at this total of 90 degrees in there for our interval. And so we take our derivative. Well, g prime of theta is the secant theta tangent theta. And so I can rewrite that. Secant theta is 1 over the cosine, tangent theta is sine over the cosine. So this is really, for me, the way I would write it is sine squared theta over cosine squared theta. And we want to set that equal to 0 to find critical numbers. We also want to know where it's undefined. And so fraction 0 in the numerator is 0, so we would have sine theta must be 0. Well, within this interval, that only happens when theta equals 0. So we're good there. And then the question is, well, this thing's undefined if cosine theta is 0. But cosine theta is 0 only down here at like minus pi over 2 or 3 pi over 2, however we want to represent it. And up here at pi over 2, 90 degrees. And so it's never undefined. And so that's it. So there's our only critical number. Critical number. So now we need to evaluate secant theta, which is 1 over the cosine, at 0 and the 2 endpoints. So g of 0 is secant of 0, which, again, well, that's just 1 over the cosine of 0. Cosine of 0 is 1, so we just get 1. Now we check the endpoints, g of minus pi over 6. Again, that's just 1 over the cosine of minus pi over 6. Now, cosine of pi over 6 is minus pi over 6, the same thing as cosine of pi over 6. Well, what the heck's that triangle? So our 30, 60, 90 triangle, if this is our pi over 6 and pi over 3, then that is a 1, 2, square root of 3 triangle. And so cosine of this angle here is square root of 3 over 2. So we get that, which is definitely bigger than 1. And then we also want g of pi over 3, which is 1 over the cosine. 1 over the, messed that up, didn't I? Square root of 3 over 2, see, that's 1 over the square root of 3 over 2, so that's 2 over the square root of 3. You need to yell louder when I do that. I can't hear you otherwise through the video. Okay, so, so cosine would have been the square root of 3 over 2, but we wanted 1 over the cosine or the secant. So again, here we have 1 over the cosine of pi over 3. And looking at this, here's the triangle pi over 3. Cosine would be the 1 over the 2. So we'll get it right this time, and our secant would be 2. And so as we look at this, that is definitely the biggest, and then 2 divided by the square root of 3, well, that's 2 divided by about 1.7. And so actually that looks to be the smallest. And so our maximum is at theta equal pi over 6. Oh wait, pi over 3. Sorry about that. That was pi over 3. I got it right here, and I did it right there. So, so is at pi over 3. The maximum is at pi over 3, and g of pi over 3 is equal to 2. And then the minimum is at theta equals 0, and g of 0 equals 1. And again, you can always go over to Desmos and look at these things. And so, you know, let's check ourselves out and make sure we're correct. So we want the secant of theta. Well, I can just put in secant of x. So we have that. And then to, you know, look at our proper intervals, we had what, minus pi over 6. Okay, so here what I can do is I can just say x equals minus pi divided by 6. And there I get a vertical line that shows me that spot. And then I can do my x equals pi divided by 3. And that gives me that spot. And so as I look at that, right, I'm in between those two vertical lines. And sure enough, right, there's the, oops, gosh, can't do it that way all the time, I guess. There is my maximum, and that was at pi over 3, and my minimum is down here at x equals 0. Oops, try that again. There we go, 0 and 1. So, all right, and we had pi over 3 and 2 there for our point. So that is, again, what we had. We had 0 and 1, and pi over 3 and 2. And, right, so there's 2 and 1. Oh, 2 and 1. There we go. And so that does it for exercise 34.